Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today. A health study tracked a group of persons for 5 years. At the beginning of the study, 20% were classified as heavy smokers, 30% as light smokers, and 50% as non-smokers. Results of the study showed that light smokers were twice as likely as non-smokers to die during the 5-year study, but only half as likely as heavy smokers. A randomly selected participant from the study died over the 5-year period. Calculate the probability that the participant was a heavy smoker. So I'd like you to pay attention to this one twist or one feature of this problem. You are given that comparison of probabilities, that light smokers are twice as likely, so probability of dying given that you're a light smoker is twice the probability of dying given that you're a non-smoker. And then the question asks you to find the probability that the person was a heavy smoker given that the person died. So you have the conditional probability flipped. You first have a discussion of what are the chances of dying given that you're a light smoker or a heavy smoker, and then the question asks, well, given that you die, what are the chances that you're a heavy smoker? Every time you see that, the question refers to using the Bayes theorem. So that's what we're going to use. We know that at this point. Start by labeling the events, and then try to figure out what you're looking for based on the information given. So label the events, write down what you know, ask clearly what you're looking for. Let H be the event of studying a heavy smoker in this study. L be the event of studying a light smoker, and N be the event in studying a non-smoker. We are given the probability of H is 0.20, probability of L is 0.30, and probability of N is 0.50. Additionally, let D be the event of a death within 5-year period. We know that probability of D given L is 2 times probability of D given N, and probability of D given L is half of probability of D given H. We are looking for probability of H given D. And then we use the Bayes theorem that says that probability of H given D is the probability of D given H times probability of H. So remember, the Bayes theorem formula has the numerator has the conditional probability flipped versus the one that we're calculating. So we're calculating H given D, and then this says D given H, multiplied by probability of H, so the thing that is after the line. And at the bottom, you have the same thing as the numerator, but for all pieces of the partition of the probability space. And the pieces of the partition of the probability space here are H for heavy smokers, L for light smokers, and N for non-smokers. These are exhaustive probabilities, exhausting possibilities. Nothing else can happen. This is the entire probability space. And that's what you have, N, L, and H in the denominator. And otherwise, the 3 formulas that are added up in the denominator are of the same type as the numerator. Okay, then we plug in what we know. So we have 2 times probability of D given L times 0.2, and in the denominator it's 1/2 probability of D given L plus times 0.5, plus probability of D given L times 0.3, plus 2 times probability of D given L times 0.2. So probability of D given L cancels out everywhere, and we are left with 0.4 divided by 0.25 plus 0.3 plus 0.4, and that's approximately 0.4211, and that's answer D. You can also solve this problem by drawing out the probability tree. And it starts always by writing out the first column of the possibilities for the person studied here or whatever's in the property space. After that, you always write the first column of the pieces of the partition of the property space, which are non-smoker, light smoker, and heavy smoker. And then the outcomes of this experiment, so the things that can happen to those people. So they can die or survive, and the properties of that happening. So we took the property of dying, given the person is light smoker, as kind of a baseline, we call it P. Then property of dying given the non-smoker is 1/2 P. And then property of surviving is 1 minus property of dying. And property of dying for a heavy smoker is 2P, and property of surviving given the person is heavy smoker, 1 minus 2P. And then on the very right, we write out the products of the probabilities of the pieces of partition. So, for example, 0.50 for non-smoker, times the probabilities of the outcomes that we're looking at. So, for example, 1/2 P. So 0.50 times 1/2 P, or 0.25 P. Then 0.50 times 1 minus 1/2 P. Then 0.30 times P. Then 0.30 times 1 minus P. Then 0.20 times 2P, and 0.20 times 1 minus 2P. And we're looking at the property for the property of H given D. That is going to be the probability that we have for the case when we have H and D in that multiplication of probabilities, which is 0.40p, divided by all the products of probabilities for the outcome when the person dies, so corresponding to D after the line. And those are 0.25p, 0.30p, and 0.40p. So you can see that again, p cancels, and we end up with 0.4 divided by 0.25 plus 0.3, 0.4, and that's again 0.4211. Answer D again. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.